Now I kind of skipped the last part because I wanted to go and do some proofs with you because we're still learning that process. Remember, when you have a proof, you have to have your statements and your reasons, and we will always do ours in 2 columns. So I have my statement sides, I have my reason side, and we always start with a given. The key thing is to make sure we always mark our diagram. So I'm going to start with our given. I look at my proof to kind of give me direction. I'm proving triangles congruent, so I have one of our many ones, which we could have, like, you know, side, 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 congruence, side, congruence, angle, angle, side, congruence, hypotenuse, leg, congruence, and I totally forgot my angle, side, angle, congruence, which was fundamental. But I can start with those. So I'm going to use one of those reasons. So marking my diagram and stuff is going to be really helpful. So the first thing that's in our given is the fact that segment BD bisects an angle. Now, if I give you an angle bisector that bisects, what do you give back to me? 2 congruent angles. Now, BD bisects angle ABC, so that means these 2 angles are the ones that are congruent. So I can go angle, and that should be an A right there. Angle ABD is congruent to angle CBD. And that's the definition of an angle bisector. And I think your book takes a shortcut and they say definition of bisector. I don't quite like that as much. Now we're kind of stuck there. So let's go ahead and use the next piece of information. Next, they tell you that segment AC is perpendicular to segment BD. Now, once again, if you don't know what perpendicular means, this doesn't work for you. Remember, when it says perpendicular, what type of angles are being formed? You should have right angles, and make sure you want to form it in both. So in my very next step, I'm going to go angle ADB and angle CDB are right angles. And the reason why I knew that, that was the definition of perpendicular lines. Now, here's the cool thing. What do we know about all right angles? They're both 90 degrees. All right, so now let's go to our theorem. We know all right angles are congruent. So I'm going to say that next. ADB is congruent to angle CDB. Now notice what I have here. I have an angle and an angle. Wouldn't it be really nice to have a pair of sides right between? Well, I do. So on number 6, I'm going to say segment BD is congruent to segment BD by the reflexive property. And then as a result, I'm going to go therefore. Okay, so therefore, I know my 2 triangles, ABD, is congruent to triangle CBD, because in the, what do I have on here marked? Angle, side, angle. Congruence. So notice we use those to our advantage. Let's do one last proof here, and then we'll be done. The next one is we have this figure. We have EF, GH, and they tell us, and I'm going to again move this up a little bit more. Make sure I got my statement side, my reason side, and I'm going to make sure I mark up the diagram and remember which angles go with which. And so here's our first one. They tell us that EF is parallel to HG. I'm going to mark parallel. And the instant I hear parallel, I start looking for congruent angles, either corresponding or alternate interior normally. And they are. There's a pair right here of alternate interior angles, the Z shape. So I go here and I go angle FEG is congruent to HGE. And my reason is because I started with parallel lines, because if parallel lines, then alternate interior angles are congruent. So I have that. All right, I've used up that piece of information, so I go back to my given once again. So segment EF is congruent to segment HG. So EF is congruent to segment HG. That's given. I'm going to mark it. All right, good. You've kind of used that given. It's marked in the diagram. Now, look what I have here. I have a side and an angle. Wouldn't it be nice to have another angle or another side? Well, hopefully you're recognizing the reflexive property. They share a side. So I have segment EG is congruent to segment EG, or you can even say GE, so you're matching up perfectly by the reflexive property. By the way, you don't have to write that part there. And once I do that, I have a side, angle, side. I have the SAS. So triangle EFG is congruent to triangle CBD, okay, by side, angle, side congruence. Well, I hope this gives you a little more ideas on how to do your proofs. I'll post these on YouTube, and hopefully we'll keep going with it in class.